Let's use today's warm-up to actually dabble with a extension of a concept that relates to absolute value equations. So you haven't actually seen this exact problem, but notice what we're trying to do. We're trying to write an equation. We have talked about writing equations of an absolute value. It has a vertex, but here's where things change a little bit. It contains a point. So how are we going to write an equation for an absolute value with a vertex but contains a point? Well, the good news is much the same that we would have done in the past. In other words, when you write your equation, you always want to use the transformation template, which basically amounts to trying to fill in as many of these values as we can. I hope that the vertex is used to help fill in h and k. That would be the main thing that's going on right now. But let's leave the letter A. Let's leave the letter A as part of this formula because we're going to find it next. Anyhow, what do you think? If the vertex is at 4, that means you have to actually use a -4, right? That's because it shifted to the right. And if it's at 1, we got to put a +1. So we have those parts filled in. Well, here's where it gets a little interesting. We have the point 7,5. Now remember what a point is. It's x and y. Literally, x equaling 5 when x equaling 7 when y equals 5. I'm talking about this x and y equaling 7 and 5. So what we can do is something that is very common in algebra. We can plug in for x and y. And as we plug in for x and y, we see that we have created an equation that we can solve for a. By the way, notice that I still have my -4 and my +1. Those are still parts of this equation. But now I have, again, an equation that I can solve for a. Just need to do a little simplifying, right? Now, it turns out that the absolute value of 3 is still 3. So we can write that as 3a, because that's a little more of the order that we're used to seeing. If you keep solving this equation, you would subtract 1, and you would divide by 3. Can we kind of do those steps together? If you subtract 1, you get 4. And if you divide by 3, you get 4/3 for a. Now, the goal of this problem was to write an equation. What we want to realize is that this a value can now also be substituted in for my final answer. It can also be part of my equation. And I'm kind of running out of space, so I'm just going to put it down here where I have y equaling 4/3 the absolute value of x minus 4 plus 1. Now the reason we have this little graphing spot is because we can actually graph this equation and we can check and see if it actually does what it said it was supposed to do. So if we graph this equation, I hope you would start at 4, 1. That, of course, is the vertex. And then I hope you would go with the slope, you would go up 4 and over 3. Maybe you want to go up 4 and over 3 again. And then you can do that backwards, right? I can go up 4 and over 3 and up 4 and over 3. And I have my graph. But the reason I know that this graph is correct is because, look, it actually passes through the point 7,5. Remember the point 7,5 that was supposed to be part of this equation? Well, here it is. And that is kind of proof that this equation that I got, which includes the 4/3, which includes the x minus 4 and the +1, that equation is my answer. Now, if you were in class, the next logical thing to do here would be to try this problem. So try it. See if you can follow the same steps that I did. Write an equation that has this vertex, the vertex of -3, 4, and contains the point of 1, -4. Push pause on the video and see if you can write this equation. How'd you do? You want to definitely start with our template. You always start with the template, but knowing that we're going to be able to fill in this point as our vertex is going to allow me to comfortably create y equals a, the absolute value of x plus 3 plus 4. Continuing, you're going to be able to plug in this point for x and y, making sure that -4 goes in for y, but 1 goes in for x. And once you have those numbers filled in, you're now looking at an equation that you can solve for a. You just want to simplify it. You end up with the absolute value of 4, which is still 4, so we can write that as 4a. We have a lot of 4's here, but if you keep solving this, you end up with a equaling -2. Now, when you get a equals -2, you want to be sure to create your full equation. Let's put that, I'm going to put that down here. So I want to create the full equation where I put -2 in there as my a value. I still have the absolute value of x plus 3, and I still have this plus 4 in the end. So what if I try to graph this equation? What if I try to graph it? That's right, I'm going to start with a vertex that shifted over 3 and went up 4. So I'm going to start at -3, 4, and then I'm going to use my slope of -2 over 1 to create some new points. I can go down 2 and over 1. I can go down 2 and over 1 a couple times, and I can do that on the opposite side, and we get the infamous V shape. We get the graph. Now, the cool thing about this graph is that it does pass through the point 1, -4. Do you see it? It passes through the point 1, -4, which is exactly how we designed it, which means that we are right. Again, my equation is all of these numbers filled in, and when I graph it, I can see that it is right. Now, today's lesson, this warm-up was meant to be like a little mini lesson. Next, we're going to, the next video, you're going to see we switch to another topic, which is also a little mini lesson, which is more of the main lesson for today, where the problems on the back of this paper end up serving as a little exit ticket for us. So find the next video, take a look at the lesson, and then you'll switch to the back of this paper, which again will be the exit problems that'll match with that second little lesson.